Okay, on this problem, it gives you data for 25 baseball players, their name, RBI, home runs, average, and their salary. And we're going to have to get some lines of best fit, correlation coefficients, and do some predicting on these this data using two variables at a time. When you look at the problem, you can see that we're always using salary as the dependent variable, the y variable, and then we're changing the x variable from RBI the first time, then the second time we're using home runs, then the next time we're using their batting average. So we're going to have to get particular columns off of this table. We can't copy here in MyOpenMath particular columns. So what we have to do is first copy the whole table. So I'm going to just drag across the whole table, right mouse click, and copy the whole table. Now I have to make a new sheet now in my Excel sheet to paste this data. Now the way I make a new sheet is I'm going to go up here near the reg1 sheet, because that's the sheet that I'm eventually going to use, and I'm going to do a right mouse click on the word reg1 and click insert. And what that's going to do is allow me to insert a new worksheet. So make sure worksheet is highlighted, say OK, and now you have a new worksheet that we can paste this data in. So at this point you can just right mouse click and choose paste or paste special, either one. We usually use paste special, and that's always the safest one. So I'm going to do paste special as text and just get that data in here. Now the first part of this problem wants you to just use these two columns, RBIs and salary. So let me get my RBI data, just my numerical data, right mouse click and copy that, or I could do Control C and go to the reg1 sheet and put those in for my x values. Right mouse click and do let's see, I want to do paste 1, 2, 3 so it doesn't lock anything up, although I think a regular paste would not lock it up either on this because we're not copying from protected cells. And then we also want the salary for the y variable. So I'll go back to my sheet and then I'll get my salary, highlight that, Control C or right mouse click and copy, and then go right here onto the reg1 sheet, click in the first cell underneath the y values, right mouse click and paste 1, 2, 3. Now you got everything for those two variables. Now it says a positive relationship, so we're doing a right tail test. It says the significance level, or my alpha level, is 5%, which I have that. And it says the R test statistic, which is also the correlation coefficient, needs to be greater than what value. So in order to have a significant positive correlation, then what does my R test statistic need to be greater than? Well, my R test statistic is my correlation coefficient, and that needs to be greater than my critical value. And here's my critical R value right here. So that's 0.3365. Now that would change at different alpha levels. So my alpha level is 0.05 and it's 0.3365, and that's the right answer for me. And if yours is a different alpha level, then change it to whatever alpha level they give you. Now this actually says, what is my correlation coefficient? Well, here's my correlation coefficient, 0.4721. I'll go ahead and type that in, 0.4721. Then it says, what is my regression equation? Well, the regression equation is I'll show you here on the graph. It's this equation right here, 0.1382x plus 5.561. You can't copy this here unless you take the protection off. So you could do that if you wanted to. Go to Review, unprotect the sheet, and now we can copy this part of this. Control C and paste that in. Now be careful with taking the protection off, because you don't want to click in any cells that's going to mess up the sheet. If you don't have confidence in doing that, you can get this regression equation in pieces by, right here is the slope, so you could copy that and put it in here and put an x beside it, then plus copy this number and paste it in. But either way, That's the equation. You can see the syntax is okay. That's what they expect. Now, do we have a significant positive correlation? The answer is yes, because we rejected the null hypothesis. That means we're able to show that there's a significant positive correlation between RBIs and salary. So the answer is yes. Now they want to see if there's a significant positive correlation between home runs and salary. So we're keeping with salary for the Y variable, but I need to replace my RBI data that's right here with my home run data, and that's in sheet 3. See, we don't have to type it in because we have it in sheet 3. So I'm just going to copy this right here, or yours may call it sheet 1, but I'm going to copy, Control C, my home run data, go to Reg 1, and right here I'm going to do a paste 1, 2, 3, and now I have in my home run data. So again, I would type in my correlation coefficient, which is 0.4499. I would get my equation and type it in, and it's easiest for me to type it in right here. Since I took the protection off the sheet, I can just copy this equation right here and put it in. And do I have a significant relationship? Yes, I do, because the 0.4499 is also greater than the same critical R of 0.3365. I'll show you that here on the sheet. That right here we do have a reject because this 0.4499 is greater than 0.3365. So yes. And now the last one, your batting average and your salary. So let's go back to the sheet and get the batting average. Control C, get that. Go to the Reg 1 sheet, and we want to put that in for our X values right here. So right mouse click and paste 1, 2, 3 that in. Now my correlation coefficient is right here, correlation coefficient 0.1722. 0.1722. My regression equation, let's get that off the sheet right here. And you can see that this one has a smaller correlation coefficient, and it doesn't explain as much of the variability. The R squared is lower too compared to the other one, but this is a small correlation coefficient. It's smaller than our critical value of 0.3365. I'll show you that on the sheet here. See, this is smaller than this, and that's why we do not reject it, and therefore we do not have a significant positive correlation between batting average and salary. So now this says, based on your analysis, if you had to predict a player's salary, which method would be the best? Well, it gives you 4 choices here actually. Is it the one with the RBIs, the home run, or the average? Or is it the average of all 25 salaries? So is it the RBIs, home runs, batting average, or should we just get the average of the salaries? Well, what we do is we see if we had a yes up here. If we have a yes to these questions, then it's going to be one of the yeses. Which one of the yeses? It's the yes that has the highest correlation coefficient. So mine is definitely going to be the RBI. But if all of these say no, each one of these say no, then there's no variable that is a good positive relationship or a significant positive relationship for the salary. So what we would do then, if none of them work, then the answer would be this, the average of the 25 salaries. And the 25 salaries are your Y values. And the average of those 25 Y values are down here in cell right here, in cell B32. So that would be the answer if none of them said yes. But since we do have a yes, we picked the yes that has the highest correlation coefficient, and that's the RBIs. So down here, my answer is RBIs right here. Now, this wants you to use whichever one it gave you the highest correlation coefficient, if it's significant. And the RBIs was the best, and it was a significant one. And so I'm going to put that in for the X variable right here. Now, remember that I don't have the data for RBIs in here. So I'm going to have to get that off the sheet one more time because it's the best one for prediction. So I'm going to copy that one, Control C, and then put that into my Reg 1 sheet for the x values, so I can make the prediction using the best variable. So let's do a right mouse click, paste 1, 2, 3, and here is the predicted value for the best variable. The salary should be 14.4. I'll put in a few more values. In fact, I'll just copy it and put it in. So let's copy that one more time. So let's Control C and just put that right in here. Control V. There's the predicted salary. You can see his actual salary was only 2.6 million. But let's go ahead and take a look at these answers, and we can submit this down here and see if we got everything. And I think we did. Let's just check it out here. You can see get some "you got it," "nice jobs," and all that sort of stuff. So we got all those parts, and we got the predicted value, and we got everything. Now what we'll find out in the next section on multiple regression is that you don't have to use just one. You could use, like here, reg2, you could use two variables and see use both of them in the prediction. Or on the next sheet, reg3, you could have used all three variables and see what your predicted salary turns out to be. So that's the end of that problem, and I'll stop this right here at this point.